Move this down a little bit. Okay, my objective today is to cover CPP08 and CPP09. If you haven't found it on my GitHub directory, let me see. The link is provided with homework assignment number 3, which I just released earlier this morning. All right. So one of the questions I got from my last office hour on Tuesday is what's exactly the difference between CPP07, 08, and 09? So far we cover 07 a lot. Most of this past 2 lecture we cover CPP07. It's just showing you how you can use a mechanism called remote procedure call to be able to help you to separate your logic into 2 pieces of program such that you gain a lot of interesting new application, I would say, for doing programming. Which we will, for the rest of the quarter, we'll come back to this topic that why having a separation is a really, really nice thing for a lot of things which otherwise unavailable to the user. Okay, so today I'm going to resume our study regarding CPP08, which is remote object, and then CPP09 is called proxy object. And both of them now were integrated remote procedure call deeper into object-oriented programming. So instead of just calling a function, both CPP08 and CPP09 is help us to remotely interact with an object. In fact, you will see that the interaction, the difference between function accessing an object versus just calling a remote function is not much of a difference, but you need to worry about a few details to do it right. Especially CPP09, we introduced the concept about separation. There's 2 pieces. One piece is about your programming. Your programming is how do you actually interact with the object? That's actually object the programming is really cares about is how do I interact with the object? I mean, depending on how you define the member function, how you define inheritance relationship, that's actually helping us to interact with the object. So CPP09, just a nutshell, is trying to separate the interaction with the object part separate from the concern about the locality of the object, meaning that where is the object? Is this object in Japan or in France or in China or in South Africa or in whatever other corner of the world? We try to separate that. The programmer can easier to focus on one particular thing to solve the problem, which is interesting. We introduced the concept called proxy, or sometimes we call it a shadow. Okay, so let's start it with a CPP08. Let me just tell you. Let's take a look at what is CPP07, so you kind of can contrast CPP08 and CPP07. So I will only talk about the client side, because once you understand the client side and the server side will follow correspondingly. So CPP07, let's take a look at WR client.cpp. Okay, so this is the CPP07. In the main program, you kind of set up. In fact, I would say the first 2 lines is just you need to set this up for any programming that you want to work with remote procedure call. Essentially, the first line is set up, how do I access to the server, which in the form of URL. This is just like when you want to access a web server, you basically provide a web link. And it's the same thing in remote procedural call. When you interact with a server or interact with an object, that object need to have a URL, a web link for you to actually talk to them. So the difference is that in RPC programming, you're not having a web browser. You're not manually using the web browser, but essentially you're using your own program to interact with the information that's equivalent to when you're using the browser. Okay, that's the kind of simple way of describing what we're doing. Okay, and the important thing is to look at this line. So essentially, I'm making a function, and I'm calling the function, and this function is called remote print, and my client was defined above. You can see that the line right below the HTTP URL line is my client you kind of set up. So this two line is really together set up a remote connection to the server. Okay, so essentially you're saying that, okay, here is my client, and then the function is called remote print, and then I basically get it done. So that's CPP07. So now let's actually look at CPP08. It's very similar, but I want you to contrast the difference. So this is a CPP08. I kind of have two function call, but it doesn't matter. You call one function, two function, or multiple function. And this one, I just have two. In this example, I have a two remote. In fact, I have a three actually. Yeah, I have a, but this one is already the same name. Okay, so I'm going to show you this piece of code. So you can see that these two lines are identical, right? It's almost identical. I just changed the name of the class. But other than that, the structure of the code for those two lines are identical to CPP07, what you have seen before. Okay, so now here's a function. Is I also have a two function. If you look at this, is the format of my client and then function name. And over here, I also have my client, but I actually, both of them are my client. And then I have a function name, but except this time, the function name is a little bit different. One is called dump to JSON, one is called set GPS label. I mean, the name of the function in JSON RPC is specified in the JSON specification file. So if you don't know what it is, I want to show you in this case. In this case is ecs36b wr.json. So this is the specification basically say, I want to declare a particular function called remote print. And the important thing here is a parameter. I have an action part. I have a JSON part to that. Okay, so I want to go back to CPP08. The specification file is this time ecs36b ro.json. Okay, you can see that now I have two functions defined. One is called set GPS label. One is called dump to JSON. But the parameter is a bit different over here. Okay, there's some difference in terms of the parameter part. Okay, so let me go back to this part. This is CPP08. So I want you to take a look at the code. The structure of the code looks really similar, but what based on your observation, what's the difference between this code and the code I showed you earlier over here? What do you see the difference here? I just show you, this is CPP07, this is CPP09. Sorry, CPP08. What's the difference, you think? Any volunteer will share with us? Yes. Sure. Let me do this. Okay, the top is CPP07, which I only going to show this part, okay, because the rest is similar. And then this is CPP09. I'm going to show you this part. So now you can actually kind of provide a little bit comparison between these two. Yes, in the back. Okay, so the first observation, thank you, by the way, is the top one is trying to use one of the argument. There's only one argument as a string. And the second one is, wait a minute, this one is still a string, right? And this one is also a string. So it's probably a little bit different. Thank you for the observation. The top one, I actually use a C string instead of regular string. But over here, when I do double quote, it could be interpreted by the system as a C string or as a C++ string. By the way, in C++, for most of the case, when you expecting a C++ string, and you provide a C string, it will automatically convert it. But it might not vice versa. So if you have a function expect to take a C string, you provide a C++ string, it won't work. So in this case, the program let me show you where that is. If you take a look at rocline.h, you can see that over here, the function called setGPSLabel, everything is a C++ string. So how do you tell whether it's a C++ string? If you have a std : string, that means is a standard library from the C++. That means it's a C++ string. But C string usually is character star or unsigned character star. That's a C style of string. So the difference is the usage is somewhat similar, but in C++ string, we have operator overloading. So you don't have to do like a string comparison. You don't have to worry about putting a terminator, the termination \0 at the end of the string. So C++ string is a little bit more overhead, but it's safer to use than C string. Okay. Okay, so what other difference do you see? Thank you, by the way, that's a good observation. What other things you see that are different between those two? So one of the things that's interesting, I want you to think about what is this 1001? So over there, I have some kind of parameter in the string, but you can see here, I actually have a 1001. And I have some kind of class name called label GPS and 1001. So the difference is very subtle, but let's take a look at the code. The code I actually showed you earlier. If you take a look at this piece of code, let's look at this line. This is really representing the meaning of the code. So the code I was showing you about the class name, you see that the third argument, sorry, the second argument, sorry, in this case is, this is the first argument, this is the second argument. The second argument is called a class name. And the fourth argument is called object identity. So I do have two arguments. One is class name, one is object identity. Then that's interesting. I want to come back to the code. Did I make a mistake here? Oh yeah, that's right. You see that the second argument is a class name, and the fourth argument is object identity, and then the label is like the third argument. So you see that I have a so the first argument is just basically provide information about which call is this particular function call. Okay. By the way, that first argument is also informational. That first argument, in fact, does not really, in this particular context, does not really help too much in the programming because I already have the function name called dump to JSON. I already have the function name called set GPS label. So this is a bit redundant. If you don't have this, if you design the program without, which means that you're confident that you already call the right function, so you don't need to worry about what action you're doing. Okay, so that is just one of the, I would say, convention that we put the string there to kind of have a double check about, okay, you really mean you want to call this particular function. And in this particular example, teaching and the learning complex is really the label I want to set to the GPS location. But why I need to provide a class name and what I call the object identity. Okay, so let me say, what's the difference between 007, CPP07 and CPP08? The main difference is that CPP08, I want to apply this function, the remote function, to a particular member function of the object. And therefore, in order for me to apply, I need to know what is the object's identity so the server side can actually apply this call to the right object. So let me put it this way. So first, think about imagining, we'll see the code, but I want to tell you that what is the thinking, how do you actually interpret this code? So first, what's going to happen is that the server will receive this call. Okay, and by the time they receive the call, they know this call is called set GPS label. Okay, this is the function call you try to apply is indeed set GPS label. But here is a big problem. I might have 1 million GPS or label GPS objects. In this case, it's probably have to be labeled GPS object. Oh, sorry, it doesn't have to be. Okay, I'll explain you why. So I might have 1 million different GPS and labeled GPS objects on the server. So now the question is, well, how do I know which particular object among that 1 million I should really pass on the label, which is teaching and learning complex, as the label to that particular object, to one of the 1 million object, right? So I have to convey this information. So what I really need is a object identification mechanism. Okay, I need to have a way to convey to the server that this is the object I would like to apply. So that's why then the server will look at is the server will retrieve both the class name and the object ID. And then use this information, I will retrieve the particular the particular object instance of GPS or label GPS. Okay, I retrieve the instance and then I can apply the call, which is the label, and then to that particular object. Okay, and then number 4, I'm going to return the result of the call to the client. Okay, so the real difference between those two is that now, instead of just to make a call, but I had to give the server some information so the server will be able to redirect the call to the right object instance, the object I created on the server, and such that it will. I mean, think about what we talk about the example homework 2 or homework 3. One of the main difference between homework 2 and homework 3 is homework 3, we start to introduce a concept called identity. So essentially, you think about identity is a person. Each one of us is a person. And so when we submit the server, so let me just use Google Map as an example. So Google use our Gmail address as our identity. So when you use Android or iPhone, whatever, it's keep tracking your GPS location, and then it will can you hear me? Okay, good. So it will create this pair called time GPS, which is the timestamp and your location. By the way, the time and the location, they're both very important. They need to get together. For example, I want to see for example, Google Map want to give you the traffic condition. How congested is the highway I-80 towards Sacramento, for example? How do they know that? They're actually looking at your time GPS location as you're driving. They actually see that how fast you can move. And then they actually collect the information pretty much from every single car on the street for the past how long, several hours. And based on that, they provide some calculation. They can determine the speed about how congested the particular section of the highway. Okay, so over there, we are associated with the time GPS pair or vector or array with each one of us. So essentially, in that particular server, we might have a 1 million UC Davis student. And what the server need to know is that, well, when you want to do something to that record, the server need to know which object. In this case, each student is an object. So I want to say, oh, I want to apply this particular computational logic specifically to one particular student or one particular identity. That's actually why we introduced the difference in homework assignment number 3. Okay, so that's basically the logic. And the difference is a bit subtle. I mean, we introduced multiple extra argument, but the most important thing is that you have to know the class and the object ID for you to actually communicate. Okay, so any question about this logic? Why don't we see the server side and then see what the server is doing? And then I will come back to talk about programmer responsibility. Okay, so here's a server. Let's go to set GPS label. So when you make the call, it's this particular function is going to receive this request of the call from the client program I just showed you. And it has 4 parameters exactly the same as we talked about before. So just, it's not surprise when you make a remote procedure call, the client and the server, they have to match every single thing in order to handle things correctly. Okay, so now the first part is unrelated to the object identity, but here is an interesting part I want to show you is that this is, I can tell you that this program is handling in a way that's kind of the simplest way of doing object identity. Essentially, in this particular program, I really only have a one object. Instead of 1 million, I only have a one object. But if you can identify that one object, you should be able to extend it to 1 million. Okay, I only have a one object, and that particular object has to be, the class name has to be labeled GPS, and the object ID has to be 1001. Okay, I have a one object with that class name and object ID. And take a look at this piece of code. I basically saying that if your object identity is not 1001, and then you don't have the label GPS class, then essentially I'm going to say, hey, this object or class not found. Okay, so essentially I say, hey, you want to access this object. I'm sorry, I don't have it. Okay, that's an error condition. I cannot find. Okay, if you actually indeed found it, take a look what I did. And I have an object called object 1001. And I directly just set the label to the object one's label. So what is object 1001? Let me take a look at what is object 1001. So object 1001, it must be somewhere. Yeah, here. You see that this is a object 1001. It's a pointer to a label GPS object. It's a pointer to label GPS object. Okay. So I declare this is a global variable. I mean, I kind of make a really simple example. The server only responsible, this particular server only responsible for one object, object 1001. Okay, and it's a null pointer. So the server side, when it first run the server, you see that's what I did. I actually create a object, which is I'm using the command new, which is a C++ version of malloc, which will allocate memory and run the constructor correctly. And I create a new object called label GPS, and the pointer, I save it as object 1001. So essentially, after I start the server, I actually have that object in my memory space. So so now after this line of code, the object underscore 1001 is no longer a null pointer. And therefore, when I call this, now I'm going to go back here. Okay, this is the line I created. Now let's look at object 1001. So now you see that when I verify that your object identity is indeed 1001 and your class name is indeed labeled GPS, I just basically call, oh, this one is dump to JSON. Yeah, but this one is set GPS label. I just basically assign directly, because in this case, label is a public attribute, so I can directly assign this label I just received from remote, assign into the label itself. Okay, so this is an example about set GPS location. But the other function, remote procedure call, is called dump to JSON. Let's actually take a look at very quickly. And it's the same logic. I'm doing this 3 check. Just try to check whether this object is indeed what you're looking for. And then when I want to call it, I just call object underscore 1001 dump to JSON. I just call the function of the local object on the server side, and I'm going to get the result. And then I basically just return the result to the server side. Okay, so that's the basic mechanism. You can see that this is a C++ object interaction. I'm actually interact with a remote object, but the initiator is from the client. Okay, so now let's actually go back to my client program. Okay, so this is now when you read this part of the description, it might help you to understand better after you look at the server side. So essentially, I just need some mechanism to retrieve the right object. And after I retrieve it, I just apply the call, whatever the call. And by the way, the call could be, I just assign a label because that is actually one particular interface we supposed to interact with the object. And then we basically just return the result to the call, okay? So you can see that when I do set GPS label, it has the result coming back. If I call dump to JSON, it also have the result coming back, but the result is somewhat different, okay? One is just reply is successful or not, but the other one will reply not just successful or fail, but also give you the whole dump about a particular object in remote. I mean, dump is kind of useful because you can actually, for example, go to a remote server on Google, say, I want to dump all my GPS record. If Google allow you to see that information, which then you can actually look at your own data and then decide what to do with that. Okay, so any question regarding what we just did about remote object? Okay, so I'm going to tell you one more thing before I move to the proxy object. I want to actually talk about the differences. Maybe I should talk. The above is a difference, but I want to talk about programmer responsibility in the technical sense, not the social sense. Okay, so a programmer doing this kind of remote object, they need to handle a few things because you want to interact with a remote object. So first, you need to know the URL to the remote server. Number one, that's the first piece of information. The second piece of information, you need to know the class name and the object identity of the remote object you try to interact with. And the third thing is that you want to really call the right function or the member function such that the call can be completed successfully. Okay, so that's essentially you have to, as a programmer, to write the client program, you have to worry about the three things. You have to decide where is that object. So essentially, this one is I call a locality issue. Okay, we'll go back. We will come back to this point when we talk about the proxy object. Okay. Okay. Any question? So after seeing this example, try to write some program, and then you can actually try to make a call. For example, you can convert your homework assignment number 3, such that you have an object that's remote. You can actually do all kinds of things. I mean, for example, if I have an array of objects, how do you do, say, a sorting, a bubble sort remotely? That's a more complicated issue than the simple example I'm providing here. Okay. All right. I assume you will go back to play with CPP08 to actually confirm whether you learned the subject. So I want to go to CPP09 right now. Okay, here is a CPP09. So I want to first show you the code, the client code. Hey, by the way, this is the same code, okay? So this is the place I made a call. Okay, can you actually tell me the difference? Let's try to compare this again. Let me kill this one. Okay, this is the call of CPP08 I just showed you, which is very similar to CPP07, except I provide the class and the object identity. But let's take a look at CPP09, which is what I call a proxy object. And I call this one, this is the way I call it. I call it, there is a pointer called label GPS PTR, and I said set label, set GPS label. It's a bit different, right? I'm actually still calling the same object, but I kind of calling it as if this object is local. If you think about that, this line is very similar to the on the server side, right? The server side has object 1001 to this function, and this is essentially identical to that interface. So essentially on the client side, the programmer is writing the code, looks like as if it's actually on the server, or as if it's actually calling local. Okay, so this is interesting. I want you to actually know this. The first question you should ask is, where is label GPS PTR? Where is the object or the real object being pointed by the pointer? Okay, if let me actually ask you the question differently. If today I'm giving you a piece of code, I didn't tell you this is a remote procedure call. You just write a piece of program, and then you actually see this particular line, which is a pointer to object and a function. That's actually a member function to that pointer. My question to you is that, will you ask this question? Where is the real location? What's the real location about that object? We probably won't ask that question, because as a programmer, oh, naturally, this is a pointer to an object, and then this is a valid method to the object. So I would just call it as if it is a local decision, right? That's typically when as a programmer, we believe that. But in this example, I'm actually trying to kind of break that conventional thoughts about object-oriented programming, meaning that when you actually see a line, looks like you're just calling a object locally. But the thing is that we're not really sure where that object is. In some sense, I'm actually giving you both the good news and bad news. The good news is that, okay, the programmer doesn't need to worry about locality. If it does, as I said here, we have some uncertainty about the real location of our object. The good news is the programmer at least in the style of proxy programming. We don't need to worry about that. Okay, that's a good news. We essentially reduce the workload from CPP08 because CPP08, remember, you have to know URL, you have to know the object ID, you have to know the class ID, right? Over here, we don't have to do that. That's a good news. But the bad news is also something, the double-edged sword, is that sometimes the programmer need to concern because sometimes, okay, if this object is actually from somewhere which is untrusted, so there's a cybersecurity issue because you access an object, but indeed it got redirected to a fake website, and you thought that's your true GPS location, that's your true credit card, and you're actually providing all your personal information, but it's not because it's remote. So it's kind of interesting mechanism about how you look at the proxy object. Okay, proxy is a concept that in today's web world is both convenient and both also to some kind of risk exposed to the user or even to the programmer. Okay, so now I'm going to explain to you that how do I really implement this such that you really have a interface looks like is original object-oriented programming, but indeed is actually calling somewhere which is remote. How do I actually make that happen? By the way, this is a more advanced application of virtual function and inheritance. Okay, we have to use that mechanism to accomplish this. Okay, so take a look at this directory that I have a class called label GPS. I also have a class called shadow GPS. By the way, the shadow GPS is the proxy. And the other class I have is GPS. Okay, so I have a 3-class GPS, label GPS, and I have a shadow GPS. So first, let's take a look at their inheritance relationship. Let's take a look at, of course, GPS.h. GPS is kind of the root, right? So in this example, GPS did not inherit from anything else. So that's GPS. And now let's take a look at label GPS.h. And you can see that the label GPS is a single inheritance to the GPS. All right, so we have a one inheritance relationship taken care of. And then I will look at a shadow GPS. Okay, the shadow GPS is a also inheriting from label GPS. So essentially, in this case, I have, let me go back to my, let me go to client. So let's first take a look at the inheritance hierarchy. So I will say shadow GPS is a label GPS. Is a relationship. Let me use this to represent the is a relationship. And then label GPS is a GPS DD. Okay, so we have that inheritance. Okay, by the way, to do proxy object, there are 2 options in this case. One option is inheriting label GPS for shadow GPS, but the other way is shadow GPS could directly inheriting from the GPS DD. That's another option, but the effect to the programming is a little bit different. But let's follow, for this lecture, let's follow this particular inheritance hierarchy. I have a 3-level GPS DD, label GPS, and then shadow GPS. I have a 3 class, okay? All right, with this class, let's take a look at the programming a little bit. So you can see here, what I did is I actually create a shadow GPS object. I create a shadow GPS object somewhere from the client side. And when I create that shadow, I call the shadow object 1001. And then what I did is I put the 3 pieces of information that's actually for the programmer's responsibility into the constructor of that particular object. So take a look at this line. So what I'm doing here is very simple, because I know in order for me to identify an object, I need the 3 pieces of information. But what I did is I put those 3 pieces of information into the shadow of the object I would like to access. And then after I create that shadow, it's called shadow object 1001. And then you see what I did? I actually have this line. I actually have I create an object pointer called label GPS PTR, and I say label object 1001. I just put it there. And then later, by the way, this pieces between the first 4 line and the rest of the code, they might not in the same function. So it means that you can create a pointer somewhere else and pass the pointer multiple level into some code, and that pointer and the original shadow GPS should still share the same memory space. Okay, so you can see that over there, I create a shadow object and I kind of casting it into a pointer called label GPS. So up to this point, when the compiler sees this line of code, it only sees label GPS as a pointer to the label GPS. You see that we do talk about what upcasting and downcasting. This is the upcasting. I actually upcast from a lower element in the inheritance hierarchy to a higher hierarchy pointer. Okay, object. So essentially I cast up in this case to label GPS. And then over here, I'm just basically now this pointer became what? It's no longer shadow GPS. It is a, what do I call it? It's a label GPS class according to the inheritance hierarchy. And then I just call that function. Okay, and the thing is that because set GPS label is what? Is a virtual function. If it's a virtual function, regardless you cast up, cast down, it's not going to change the function that you would like. Let me ask you, what's the definition about virtual function? How do I decide which version of the function set GPS label I should call? Do you still remember that definition? Yes, please. It really, no, it's any function that depends on the parameter. But the definition of virtual function, by the way, thank you for answering that question. But the important thing is the virtual functions decide which exactly function to call is really depending on the creation time. The time when the object was created, what was the data type or class when the object was created. It doesn't matter you upcast, downcast, you move the pointer somewhere else. It doesn't matter because at the time you call it, it will look at what was the class when you created. So when was the object created? The object was created over here in this line. This was the object creation time. This was the object creation time. So I essentially create this object, shadow object 1001, according to the shadow GPS. If it's not a virtual function, then cast up is going to change the function you're going to call. But it's a virtual function, so even though I cast up to this pointer, I cast up to be a label GPS. So if the compiler take a look at this particular line, they will thought that label GPS pointer is a pointer to the label GPS object. So similar this line here, So if set GPS label is not the virtual function, then this is going to call the function that's associated with label GPS pointer. However, because it is a virtual function, then this set GPS label is going to apply to the shadow GPS version of the set GPS label. I'm actually trying to convey two concepts that's important. First is, what is a virtual function? I mean, virtual function is all about creation time. When the object was created, what's the class? What's the function that's associated with this object at the creation time? So at that point, that relationship has been fixed. And then subsequently, you can cast up, you can cast down, you can do all kinds of changes. But as long as the memory space is still the same, it will call the function that's being set for this object at the time the object was created. That was actually unnatural for most of the programmers, because up to this point, if you're Java programmer, you're a Python programmer, whatever the function behavior should associate with the type about the object at the time you call. But now this is different. This is not the time you call, but the time associated with the object that was originally created. Okay, I hope I can tell you this concept multiple times, so make sure by the end of the quarter, you really kind of print this in your learning about C++. Okay, this is one of the very unusual part of the C++ programming language. Okay, all right, that's the first part. The second part is that because that mechanism, now I can do something called polymorphism. So polymorphism means that if you take a look at this, you saw set GPS label, the behavior is already determined. The reason is no, because we don't even know where is the object really is. So this is another moment that you start thinking about, oh, the programming, but I'm not even sure where the object is, or where the integer is, or where whatever variable you're dealing is, because it might be remote, it might be somewhere else, but it might be local. And that's the mechanism. That's kind of both a concern and the beauty about this design, that you can actually create lots of interesting applications which help you to organize the resources available on the internet, for example. Okay. All right, so now I hope I give you some information about high level, about how you can actually put the shadow GPS, which contain the information for me to do object identification. And then you can actually call that method this way, okay? I still have not answered this question, just to let you know. I haven't actually even answered this question, not yet, but hopefully at the end of the last 2 minutes, I'm going to come back to this question. So my next step is going to show you the design of shadow GPS, that what's needed to design the shadow GPS class so it can actually help us to provide this kind of transparency to deal with the locality issue about the object. Okay, any question up to this point? Okay, let's go to shadow GPS. By the way, you can do shadow anything you want, just using shadow GPS as an example. So so this is shadow GPS is inheriting from label GPS. And just take a look at the design of the function. Okay, I want you to take a look at this. What's your first impression about the design about this class? I mean, from the design, I want you to guess what is going on here. This 6 lines. what do you see from the content about the shadow GPS class we just defined in front of you? So it has three attributes. It has three attributes, which related to the locality. Host URL class, over here I said class ID, but it's really a class name, but I put it in the variable name, class ID, and then object ID, right? That's the three variable. Let me ask you a question. If I create a shadow GPS object, does this object has a latitude or longitude? Does this object has a label? It has, right? How does it have those things? Through inheritance, right? Because it's inheriting from label GPS. So it has the longitude, it has the latitude, and it even have a label as the label GPS. But I want to just tell you that this, by the way, this object in its implementation, later we'll see the implementation, it never need to use those three attributes. It never need to use the longitude, latitude, and label itself, even though those are available to this object. So it actually wastes some amount of memory to have those because of that inheritance relationship. But the thing is, this is later, I want you to think about why I don't need to use that in terms of programming. But at a high level, I want to see that the purpose about the shadow object or proxy object is just providing a redirection mechanism for your call to go to the real object. The real object is going to be identified by host URL, class ID, and object ID. That's like a remote pointer, the information to pointing to the real object on the other server. And therefore, when you want to access the longitude or latitude, you should actually modify those two values on the remote side, on the real object. That's why it's a shadow. It's not a real object. It's just a representation for you to use the shadow to actually connect it to the real object. Okay, so that's why, number one, I should probably say, yes, it has longitude, latitude, and label, but those will never be used. Those should never be used. Because it is just a shadow. Okay, so first, let's understand that part. Okay, and then let's say this line is constructor, right? The constructor take a 3 C++ string to initialize these three variables. Okay, that's just a constructor. And then it has this two function. One is set GPS label, one is called dump to JSON. They're both virtual function. Okay, they're both virtual functions. So that's the design of the class. Okay, let's actually take a look at the shadow GPS.cpp. Okay, shadow GPS, as you see that the constructor is just like this three thing and set up the three attribute. But now let's actually take a look at, let's see, let's first take a look at set GPS label. Okay, so now have you seen something familiar? Like what you see before? The first three line, it looks like is the first three line that in the main program for CPP08 and CPP07, right? This first couple line, there actually looks like the same. And this, in fact, the entire thing looks really similar. What I just did is that I took the code out of CPP08 and CPP07, and then I just basically put it in a member function called set GPS label. And the same thing is true for dump to JSON. Is again, I'm actually having the same kind of piece of code to handle the JSON RPC and to actually make the call. Okay, so what I'm doing here is not too surprised. It's just for me to move the code out of the programmer's presence, and then I move those code into something called a shadow. And within the shadow, sorry. Sorry. So within the shadow, I'm actually really make the call. If you take a look at this piece of code over here to call my client.set GPS label, this piece of code, let's actually compare with remote object in CPP08. Okay, if you take a look at this piece of code, let me just move on. This was what you see in CPP08, and this code is you have in CPP09, but inside the shadow GPS.cpp instead of the main program. They're essentially identical, but parameterized. Okay, so over there, I kind of hard-coded its location, its parameter, and whatever. I actually hard-coded over there. But over here in the shadow, I basically pulled out the three pieces of information, the class ID, object ID. By the way, the URL was actually used here. If you missed it, the URL is actually used in configure the client over here. So over here, I had, you see that this is the line that's comparison to this. I actually has to hard code it, the URL. But over here, I just basically, when you construct the shadow, whatever URL you provide, I'm going to use that URL to do this. So this actually gives the programmer some flexibility about how you can put, for example, you can actually change the URL such that, for example, you try one server and that server is not working. So you just modify your backup URL into the shadow object. So it will go to the secondary location to try to retrieve the same object. So that's actually very commonly used today as a replicate services when you have some part of the object is not available. Okay, so so you can see that when we show you a trick. By the way, this is a really interesting trick because it kind of separates the concern about how you can reach the object from the interacting with the object. And therefore, when you design it this way, that you really have a lot of flexibility in terms of your programming. Okay. Any question with this piece of code? I hope I convinced you that you can actually do this kind of trick called, sorry, I want to go out, called shadow object, and such that you can just call this function. But just to let you know, I actually did check whether the result, I actually checked some result, whether the result from here is correct. And then if everything is correct, I would just return the result. Okay, you have to decide what's the result because the result returned from the JSON is the result from a remote procedure call is going to be a JSON. But the thing is that when the C++ program, they want to interact with object, in this case, I want to actually get it as a Boolean value. when you do the set GPS label. Or the other function, you can see that the other function which we declare is dump to JSON. And in this case, dump to JSON, I don't have to check. I can directly return because I'm actually expecting the application program expect to receive exactly the same information I will get from the RPC call. So I don't have to do that kind of tweaking in order to get the right thing. Okay, so this is the program called Shadow GPS. It has providing some kind of proxy or some kind of shadow to the real object to actually help you to redirect. That's what I want to say. Any question? Okay, I'm going back to the program again. Okay, so now I have this line over here. That's when you have a label GPS PDR, you do set label GPS. That's a line is supposed to call shadow GPS. Okay, now I want to go back to ask you this question. And then I'm going to talk about homework 3, part 2. So when you see this line here, you have a label GPS PTR. So now I'm going to pose you the kind of question I asked earlier. Where is object? Can you actually tell where is a real object? First, by the way, when I ask you real object, do you know the difference between real a real object and a shadow object? By the way, do you understand what's the difference between a real object and a shadow object by now? If not, that's okay. Go back to play around with CPP09 or ask me to explain again. Okay. But okay, so when you run this program, by the way, do you know where the real object really is? Okay, as a programmer, we really don't know. But how do you know that whether this is a real object or shadow object? How do you know that? Okay, so I want to tell you that there is a few things you can do to answer this question. So first, can we track the code to find the creation moment? Can we track the code? I mean, in this case, we can't. Why? Because the code is just above. So I can trace the code and realize that this is the original line. That's actually create the object. Okay, in this case, we have to go back. And then where's the object? We find this moment and then realize that this is something like that. But on the other hand, let me actually create another object. Do I have an example here? Oh, wait a minute. I'm going to copy something. I'm actually going to create another object. I call it label GPS. I call it real one. And then I'll just use the label. And then I do this. if I do this, sorry, I have to do this. I cannot do this way. Okay, if I just want to test you, okay, you understand? If I write the code this way, this first 6 line exactly like what I'm putting down here, okay, and so this is the line, 6th line, and then down below, I try to make this call here. Where is the real object? I asked the same question. If I had the line in front of this or whatever logic, it looks like this. If I can trace it. And then I'm going to call that function, label GPS PTR. Can you tell me where's the real object? You understand the question? I want to make sure I'm not confusing you. So let's say we have two options. One is that the object is a local on this computer, and the other one is actually on a remote URL, assuming this is Google or Facebook, whatever I put in here. So I wonder, in this case, where's the object? Is this in URL, which is Google or Facebook, or this is in a local computer? Yes. It's in URL. Why? What? Okay, so if you're right, what's your name? Jote. Okay, so Jote, if Joe is right, then essentially he is saying that that label GPS pointer is a shadow, and the real object is belong to that URL by the Google, right? So it means that we have to trace the pointer of that label GPS pointer, whether that particular, the object was actually pointing by the pointer was created as a shadow or as a real object, right? Does that make sense? Because it's always about where, I mean, how it was created, whether it's created as a shadow GPS or is it created as a real, because here we have a two object. You see that I have a two object. One is a real object. By the way, the real one is actually locally in my memory. This is not a shadow object, it's a real object. But this one's a shadow, it's actually pointing at the object somewhere else, okay? And so this is a real, this is a shadow. But then over here, let's determine what was the latest assignment to the pointer. So it's actually pretty much here. The latest assignment to the label GPS pointer over here was the real one, right? I mean, sorry, some of you might have missed it. I actually add this line here. So what does that mean? Means that I'm actually taking the real object on that machine, their pointer assigned into label GPS pointer. So in this case, this label GPS is pointing to the real one, which is pointing at the real label, local. Real means local label GPS. And therefore, when I call that function, it's a virtual function, it's purely determining at this time. This is object creation time. This is object creation time. Even though I actually play around with a pointer, doesn't matter. It's still the same object that referring to this one. So in this case, when I actually call label GPS pointer, it's actually going to call the real one. So the true answer, I mean, thank you for trying. That's a good try. The real answer is, in this case, is actually going to call the real object. The real object is actually local in this case, okay? All right, so if I modify one line, just one line, it changed the result. I just actually get rid of this line. If I get rid of this line, Then the last update value for the label GPS pointer was this line, because I get rid of this line, right? The latest one was this one. So label GPS pointer is pointing to the pointer to the shadow object. And the shadow object is over here. It's a shadow. It was created here. And therefore, the virtual function mechanism will make sure that that label GPS pointer pointing to the set GPS label is going to call the function that was defined in shadow underscore GPS.cpp. Okay, it's actually very difficult. If you think about that, it's very difficult to actually understand. So the virtual function is a mechanism. You have to be careful because if you only look at one piece of code, you really have no knowledge about what was the last update about that particular pointer or whatever the reference you try to use. And therefore, you actually don't necessarily know what was the original type that was created, either this line or this line. And depending on how you actually set it. Of course, the programmer need to be careful to actually handle it correctly. Okay, so that is a number one trick that you have to remember this rule about virtual function. Okay, number two is important, is that this is sometimes confuse people, but it's a great feature. That when I actually call this particular label GPS pointer set GPS label, all the programmer care is that this particular pointer is pointing to a function that will support this particular member function called set GPS label. That's the only thing the programmer ever know. That say, hey, there is a real object somewhere. I don't know where it is because as I told you, it's hard. It's really hard for programmer. I mean, if you have a 1 billion object, it's around the whole world with some kind of replication. It's really hard for us to know precisely which object you're accessing. But the thing is that the only thing I know is it will support the interface. What I really care as a programmer is I want to interact with the object properly. And therefore, I don't really care where it is and how it was supported because there's some other part of the program is going to take care of that, such as a shadow. So this has become a programming style, kind of, how do I say that? Kind of uncertain or kind of convenient, depending on how you look at it. But it actually allows us to manage object in a really large scale, especially if you want to create a service that could have a replication, could have a distribution, and some of the object might be just locally. Okay, for example, let me give you another example. I have a YouTube video. Okay, you want to access the YouTube video, right? So when you want to access the YouTube video, you typically go to one of the Google server to retrieve the kind of chunks of video so you can play. But one of the things is, assuming this line is about the player, about that movie, I'm actually playing one segment of video. But the thing is that what you want to do is that at one point, you actually retrieve the video from one of the Google server as an object. So now you're interacting with the object remotely. That's a remote object. But on the other hand, you can also, after you retrieve this chunk of memory, you actually store locally. And then you actually set the pointer, that line you kind of unblock. Because why? You actually realize you kind of make a local copy of your movie and you unblock this line as a pointer, and then you actually use the same code. Now you're accessing your information locally. So it's not only you don't know where the real object is, but more importantly, that relationship about where the object is can be dynamic as well. You can change. When one thing is closer, you use the closing one, the one that's closer. Something is fail, you can use the other one. Okay, so this paradigm, it looks simple, but it has a lot of interesting application to do object-oriented programming. Okay, All right, I'm going to stop here, and next time I will talk about the part 2 about homework assignment number 3, okay?